I guess hydraulic human-like tendons are now a thing. There's a new flying drone that's also a lifesaver if you fall off a boat. So next time you're drinking while canoeing or whatever, this thing might just be able to save your life. A label maker powered by artificial intelligence allows you to make all the everyday objects in your life way more silly. I've always called staplers paper chompers, so it's not new to me. Bloomberg goes into depth about how Google's DeepMind turned from a research project into a product maker. SoftBank has a fascinating new AI tool that makes angry customers actually sound calm to the customer service reps on the other side of the phone. So you really can't yell at them anymore. The Wall Street Journal dives into how Satya Nadella at Microsoft is building an AI empire, and OpenAI was just the first step. Medium author Yumo Bai writes a fascinating article explaining why it is exactly that most LLM models are decoder only. And I'll explain the whole encoder-decoder thing just in case you're not up on that. The US Navy now has AI-powered underwater drones looking for enemies. Joining Microsoft and Google, OpenAI is now pushing into the healthcare sphere. They partnered with Color Health for the new cancer Copilot. Fascinating conversation by an Anthropic employee says that AI is not just learning next token prediction. They are discovering semantic, meaningful connections in novel new ways. We're talking about, honest to God, creativity. There's no other way to put that. But first, let's check Alan's conservative countdown to AGI. And, you know, this week we had the big move up to 75, and we're still there, which hopefully will be here for a little while. But our last big milestone was still that Claude 3.5 sonnet, the better than PhD level GPQA score, and wow, we made that move. We're 3/4 of the way there to creating general intelligence on silicon chips. All right, let's start by talking about the most uncanny, eerily real kind of robot hand I've ever seen. This is some prototype musculoskeletal body arms, hands, like things that are done with tendons. I mean, technically I can call it a robot, but it's different because it's the tendons that are pulling with hydraulics on the bones the way the hand does. That's why it looks so real, but also kind of moves inappropriately to like what we would expect from a human muscle. So yeah, their goal is to create low-cost humans. I mean, low-cost humanoid robots. All right, so you can see here that it can hold a drill and press the button like super fast. With a little bit of help, it can grip a tennis ball in the way you would throw, you know, a baseball or something. That's fascinating. And yeah, it looks like, I mean, you can put the tendons everywhere on the human skeleton that we actually have tendons. So you can get the form factor, I guess, essentially much closer to perfect. I guess you still have to have like batteries and push the air around and stuff, but maybe you could put that kind of part where the heart is and then push the air through the same tubes. Like maybe this is how you get to like really realistic robots. Let's see, in the comments you see wonderful with heart eyes. Okay, positive comments so far. Why don't they just map the reflex and motion of an animation? Data plus AI plus hardware, you'll have all the data you need. Then assign data to the correct artificial muscle so it actually behaves more in sync with humans. So if you're learning the movement, then you're asking AI to make the prediction about how much air and at what rate to put into each of the tendons. Yeah, my guess is that Nexus 6, is probably right, because it's not like you can really take the data from blood flow and then teach that to the system. So yeah, maybe just work backwards, or work from that point. There's a lot of ways the AI model could learn it, but that one actually makes a lot of sense to me. Looks like a project that's full of potential. Westworld. Yeah, kind of. I did kind of think that. So sometimes I just come across stuff that's like surprisingly logical and simple, and it's just kind of like, I wonder why nobody built this before, and I haven't seen this. Every time I've ever watched Baywatch, which I've seen too much of that. You know, the heroic story is that Pamela Anderson will run out into the ocean with like her swimming skills and go save somebody who's drowning. Like, wouldn't it make more sense if some nerd in a basement who's like really good with video games was actually, instead of there, sitting in one of those cool lifeguard beach towers on the ocean front and just controlling one of these things? I mean, you could zip that thing to somebody drowning in an instant. A computer vision system could look out in the ocean to see if anyone needs it in an instant. You could overcorrect the system. So yeah, it drops it on some people who didn't need it, but you're like, no, I'm fine. You yell back at them. Maybe there's a little microphone. You can talk to them on that device too. And they're just like, I'm fine. It's like, okay, I'll just pull it back. Enjoy your day. This is like, I know this seems like I first saw it and I was like, oh, it's kind of novel. And then I thought, wow, could this actually save so many lives? Starting with just a human who powers it and drops it on people, but you start learning that data into an AI system. Then you make a computer vision system that just sees anytime there's a human, just drop this thing off on them. It could just look 24/7. If you ever see a human outside of a boat, on a cargo ship or whatever, just instantly drop this thing. No harm if you miss. Let's check the comments. The end of lifeguard jobs? No, there'll still be jobs for lifeguards. They'll just change. I think it's perfect to deliver pizza. Need to make the propellers bigger so it can lift somebody to safety. To me, that seems like you would need so much power. I don't know how possible that is, but keeping someone afloat while you can go get to them makes sense to me. Good invention. Fire. What took them so long? I don't know. I never thought of it till now. Fire, that is cool, good, beautiful, thumbs up, brilliant, absolutely amazing, very good, thumbs up all sorts of times. Yeah, they get it. Comment section gets it. All right, but if you're looking to make your life more silly, I also have the AI Silly Label Maker to show you. So Art Boffin created this as part of his residency at OpenAI. And look, you just take a photo and it uses the Vision API to come up with a new funny name for it. Then you just stick that label right on. Spicy Rooster Booster, Saucy Squeeze, Paper Chomper, Spiky Sunbather, Blaze Buster, Vampire's Bane, Yellow Boomerang, Stabby McPoke. See, the comments are big fans of Yellow Boomerang. That was one of my favorites too. I think I liked it even more than Stabby McPoke. Release the damn thing and bring back Sky. Okay, Sky is gone. She's been lawsuited to death. Let it go. Things took a dark turn with McPoke. No, I didn't think, is that dark? It's just a funny way to use a knife. I don't know. Yeah, stab. Yeah, I mean, like, but I assume they're stabbing, like, food or something. All of these things are already labeled. What is this adding to the world other than artificial desire to purchase another piece of electronics and wasteful plastic? I don't know. I mean, you're right. It makes the world a little funnier, I guess, though. Oh, yeah, keep the NSA out of our sauces. That's true. OpenAI, oh, they got that guy on their board now. Actually, now I think about it, that's a pretty funny comment. Yeah, keep the NSA out of our sauces. Yeah, just too much, too in depth. All right, so Bloomberg, which does really excellent writing, kind of long-form writing, especially in the business section, talked about how Google DeepMind, which for years and years we saw create all of these things like AlphaFold and these video game competitions, the big Go thing that took over Chinese media, like they were pushing what was possible with reward functions and creativity. And now, because of OpenAI dropping ChatGPT and it becoming so quickly integrated into the whole Microsoft ecosystem, and their response to take what was a research lab and people who really cared about AI in a different way and turning them into a product team that has to build stuff that is more compatible, that integrates, that can be built upon more as a platform, has been a pretty fascinating shift for Google to take on. Now, Google DeepMind was Demis Hassabis's baby, right? This was its own company and it had these really high aspirational goals. He's somebody who cares deeply about the way AGI in the future will play out. And that was his intention with his original company. He's always been the face of it. So you have to remember that Demis Hassabis created DeepMind in the same way that OpenAI was like its own thing for a long time and then partnered with Microsoft. Demis Hassabis and DeepMind had these aspirational goals for how artificial general intelligence is going to change the world in the long run. Like their original mission was create general intelligence and then solve all of the world's problems. And when they were acquired by Google, he maintained a ton of control over that and said, yeah, like you can benefit from this. We'd love to use your computation and all sorts of amazing benefits that you have, but I want to be able to do my own thing. And he was left to do that. And that's why the kind of things that came out of DeepMind, like playing Go, the reinforcement learning revolution, the video game stuff, and then AlphaFold, one of the greatest tools that science has ever had, were all in service of a better world. So to me, he's always felt like kind of the person that I've been rooting for as probably the best leader. But you know, with that kind of an angle, it's not very product focused. It's not going to make as much money. But of course, Google knew this, right? Like they have to also integrate AI into all these products. They have to use it in a much more product focused manner. They need to make a lot of money with it because they're investing so much overall. So they also built this amazing team that had amazing researchers and really top minds that worked completely separate. And it was more product focused, called Google Brain. And they worked separately for the most part. I mean, they could learn from each other if they wanted to, but for the most part, they were even developing their own large language models and they were building their own computational stacks and all of these things. So they didn't really merge. But then when OpenAI put Google hot on their heels, and Google didn't have the kind of products to respond, but they did have the talent and resource. It was just spread out and kind of working in weird ways that weren't making it super leading in the way that the consumer is and the way the investors are and the stock price. And also the fact that ChatGPT literally looks like the greatest threat to Google search, which is where all the money comes from. This had to be addressed. So Sundar Pichai, puts them all in a room and says, hey, I understand we had these agreements. I liked you doing research on your own, but here's the situation I'm in. And I'm not going to be CEO if I don't fix this problem. So can we merge the companies? And then the conversation started well, we were promised the ability to do research, but then Demis is, seems like a smart guy. He also understands it has to be product focused. You'll see later in this article, in fact, I'll find it towards the end here, he even says products can help research. Hastabis even made the case that researchers working on foundational science should embrace commercial development as an asset. He agreed to assume the new role partially because the AI models are becoming more versatile and developing commercial products yields techniques that are more useful for pushing the research forward. And there's some truth to that, right? Products out there in the real world, you get to see them, people get to use them as a platform, they build on them. You get a better sense for how it all comes together. You get a lot more players on the team essentially. However, you also start getting pushed around by people who need to make money and businesses that expect certain things, and it becomes a more for-profit oriented project. And that's why Sundar Pichai, when combining the two, promised that we're going to carve out all of this research. We're going to do foundational research and we're going to do products, but we shouldn't be building multiple large language models, for example, especially because they learned from OpenAI that there really is no top to scale. And scale is something they can do if they, get their ducks in order. So there ends up just being this fascinating drama. I mean, it's the story, it's a human story of people who want to do research, but they also want to make money for the company they work for so the company thrives, but not too much, and they don't want to bend their morals. But there seems there's so many variables, being integrated over on that side, at the Google side. And I still have kind of hope for it. Sometimes I think that approach does yield in the long run sometimes a better product where you can clearly tell that OpenAI is just Sam Altman is a startup guy. He's move fast, break things, make money, disrupt industries, get in there before everyone else, build your moat. He's just such a money guy, such a product money guy. And yeah, we'll do it in a safe way, but safety's probably a secondary concern, and at least it feels from the way he talks about it. And he doesn't usually address the bad outcomes very often. He's they're possible, but I see this utopic future, and it's all going to be good. It could be the beautiful age of Renaissance. Could be. That is one of the scenarios. But to me, it doesn't feel it feels he kind of picks and chooses the variables that he wants to push. So all in all, I have some pretty high hopes for Google in the long run. I mean, it does seem like they maybe have a larger group that's more morally driven by what they're doing than Microsoft does. Also keep in mind that they have an infrastructure that's quite a bit superior if it all gets aligned in a weird way, because they build the whole stack, right? They have the TPUs, they have the parallelization layer of software, which is the same as CUDA at NVIDIA, which is really why NVIDIA is one of the biggest, or is the biggest company in the world now. And they also have the researchers and the data on top of it, and the longest history. So they can get their stack together to do some things that I think even Microsoft, because as powerful as Azure is, the super cloud, the billion-dollar Stargate cluster, as powerful as AWS is, all of their servers around the world. I mean, Meta is probably not even a major player in that same way, except NVIDIA, who does the whole stack. They have the CUDA layer, they have the parallelization layer, they have the whole thing. That's why they're the world's biggest company. Google's next. They're building the full stack, and they have the research, and they have the products, and they have the users, and they have the data. They have the best components. If it was a puzzle, they would have all of the best pieces individually. And if they got those all aligned, they really could be still the best in class. But, right now, too disorganized. Other people are sort of laser focused in certain ways. There's partnerships between Microsoft and NVIDIA and OpenAI that look like they're gelling in a way that's just more focused. Yeah, I would say they have secondary pieces, but they're aligned and making them the first place player right now. So I have hope that Demis and Sundar and those guys can, you know, cannibalize their own product and take Google search out of the mix from their revenue model and make it based on something that we pay for, like $20 a month or something for Gemini, which aligns Google with the customer, not with the advertiser for the first time in their history. If that can become their primary source of revenue and their platform of AI, that could actually be a better thing. So we'll see how that plays out. So SoftBank has made a new AI that makes angry customers sound calm on the phone. Kudos to them. So good news for any of the call center operators who are worn down by hostile customers with unreasonable demands. There's new AI technology that makes angry people sound like they're just more reasonable. Now, at first I was thinking this was an article where it was kind of like summarized what people were saying and changed the actual text, which probably would put us all in our own little worlds. But as a customer service product, this just plays with the tone. And it seems like it comes from good intent. I mean, SoftBank Corp is going to productize this. They're hoping that in 2025, I think it said that they were going to try to release this for everybody to use. But they announced that they're developing this voice altering technology that's meant to protect their customers from harassment. You know, like I worked at Zappos for a while, and I know that their customer service was a big thing. I kind of know how their phone support works, and yeah, that can be pretty psychologically hard on people who are just getting paid, you know, reasonable amounts of money to try to fix people's problems. And usually the burdens that make people angry are more systemic, and they're not even on the call center level. So you have to be patient with these people, but also you can be frustrated that the company itself has built systems that aren't very, you know, good. But I digress. But to SoftBank's credit, they were thinking about this 3 years ago, before AI was like a hot product, you know, and they launched this study, and it was on emotional canceling, which I kind of find hilarious the way that sounds. And it uses AI voice processing technology to change the voice of a person over a phone call. So 10 actors were hired to perform more than 100 phrases with various emotions, training the AI with more than 10,000 pieces of voice data. And the technology doesn't change the wording, just the pitch and inflection in the voice, so it's softened. It can do the other way too. So if a woman's high-pitched voice can be lowered in tone to sound like less resonant, and probably most of the time what it's doing is it's removing bass. So like a man's bassy tone, which may be frightening, is raised to a higher pitch to sound softer. So the Wall Street Journal did an amazing deep dive into how Satya Nadella is actually building this amazing AI empire that's way bigger than OpenAI. And I don't think I really realized it till I saw just how many international investments they're making. Okay, so for example, Microsoft invested $1.5 billion in G42, which is an AI technology company to strengthen AI and cloud services in the UAE. They're putting a ton of money into Wisconsin. So $3.3 billion aimed at building a data center, establishing an AI co-innovation lab, and providing AI training to over 100,000 people by 2030. You know, at some point I was just like, why don't they just provide AI training to like everyone in the US? Like, but then it's corporate owned education. And then I was like, oh, okay, that's not a good idea. So in Japan, Microsoft committed $2.9 billion to enhance AI and cloud infrastructure, including training 3 million people in AI skills and opening a new Microsoft Research Asia lab. In Indonesia, they invested $1.7 billion focusing on AI and cloud infrastructure, aiming to train, get this, I'm not kidding about this number, 2.5 million people in AI skills. Like, that's crazy. There's so many people who have the opportunity to learn AI skills directly through Microsoft and probably be employed directly by them right after. That's amazing. In France, Microsoft is making more than a $4 billion in US numbers expansion to the generative cloud and the AI infrastructure they're building. They're bringing 25,000 of the most advanced GPUs to the country by the end of 2025. In Malaysia, they're investing $2.2 billion to boost AI transformation, train 200,000 people, and enhance cybersecurity capabilities. Satya Nadella has got the CTO to just do whatever he wants, it feels like. I mean, I guess when the company is just jumping up by trillions, the CTO's like, oh, fine, whatever you want. There's definitely going to be a $1 trillion supercluster in the next 3, 5, 6 years. Like, won't that be the biggest project that's ever happened on Earth? Like, has there ever been a $1 trillion project, really? I mean, now we're just talking about astronomical numbers. All right, so let's talk about Yomo Bai. She is an author on Medium, and she wrote this fascinating article called Why Are Most LLMs Decoder Only? I just love when I come across reads like this because she clearly had a real thought, like, why are these things built this way? And went to look them up and wasn't really sure if she was persuaded by the people who gave her answers. So she did some digging, and it turned out to be this fascinating rabbit hole to dive into. But first, we have to understand and talk about encoder-decoder in a super general way. And what we're talking about is transformations, compressions, abstractions, filters. Like, it's very hard to just pin it with one word. But if you take like a room full of junk and you distill it down to its essence, its meaning, its semantic meaning, they often say. It's a compression of what's important into something that's smaller and more focused, I would say. And then the decoder is taking whatever is there, what that becomes is like a latent space, I'm going to call it for this conversation. What that latent space is some kind of a captured moment, like a thing that has all this other information in it. And then it gets translated also. Like, so it gets translated from, in her case here, from an English sentence to its equivalent in French. Like, the meaning is actually still the same, but it's translated, it's decoded into a different way to utilize that data. But English to French makes a lot of sense. It also can be much more advanced, like a Google model from video into audio. And it's starting to become like a much bigger translation in the decoder side. So you can have models that are just built with like raw input data in, like ChatGPT just like read the whole internet, they just dumped it all in there, and then you can like decode out of it the information that you need. Or you can even, which you don't do all the time, but like we've seen with Anthropic, they were doing that to learn about how systems work. You sometimes can just encode only, like you just take raw data, compress it for some reason. So then she does this great breakdown of like what models in the past had actually been done that way. So BERT was a model that Google came up with, and it was an encoder only model. And then there's encoder decoder models, which is what T5 BART and presumably even Google Gemini is using. Putting a lot of AI processing in the whole ingestion process. Like the first thing that they're getting is more semantically meaningful, which makes me wonder if in the long run, especially knowing that Google has that whole TPU kind of CUDA layer built on their own thing, they can get all aligned with their employees and all of that stuff, if that could end up becoming the more superior model. So why are most LLMs decoders? That is because they benefit from simplicity. So it's zero-shot generalization they're better at. You don't have to give them as many examples to help them like hone in on where the compressed data was. They have lower training costs compared to encoder-decoder models because you don't have to use a bunch of AI to like compress the whole internet. It turns out that it's just easier to throw more and more GPUs into these servers and just say, consume the internet faster and faster and learn that way, instead of like thinking about how to compress it. And if you did compress it wrong and you like captured the wrong features, then the model can kind of go off a little bit. Whereas if you just digest the whole thing raw and then let the question, the other side, the decoder side, go figure out where everything's positioned, it just ends up being a little bit more accurate, cheaper. But it's worth keeping an eye on the encoder-decoder model, because even though there's a lot more to work out there, it's a little bit more difficult. The potential is more powerful due to their ability to process and generate data that requires more complex and costly training processes. So, think about this. If you do compress the entire internet kind of correctly, so you have this smaller version of the internet, but it's got all of the best semantic meaning, and it understands what's good and what's bad, and then it's an encoder-decoder model, stuff goes in and it comes out, and then the stuff that went in has meaning in it already, it can actually look at what came out of the other side and make an assessment on whether or not it's good, it's quality, it makes sense compared to what it already knows about its compression of the first internet, like the meaning, the semantic meaning, the focus, the truthiness, I think they call it, like that's in the first model. So it makes a better cycle if it's going to correct itself. So an encoder-decoder model could be a better system if it starts iteratively and recursively fixing itself and updating itself. So it's an interesting article to read. Great author. Check her out on Medium. All right, but now let's talk about how AI-equipped underwater drones are helping the US Navy scan for threats. So interestingly, if you think about a submarine, it's kind of like a Tesla in the sense that it has cameras all around the car, but instead of cameras, it's radar. Like these submarines have been designed from day one to use sonar to navigate. Like that's how they see in the ocean. That's a pretty fascinating data source that you can build around. And like a computer vision model, you can have a computer sonar model. And you can train them for certain patterns that you find, including some camera footage too that's on there for like fish traps and explosives and all the things that the submarines kind of look for. And as you're having like seasoned submarine sailors who understand what they're looking for and how to identify these things, teaching the system, it can get better and better. And then when you have that kind of a system, you can deploy it on a drone, like it's big enough to hold a CPU and to have the same kind of sensors and to compute and doesn't need to come up for air as much. And you can kind of redesign the whole thing, you know? But as of right now, what they've implemented, supposedly this new AI can help them time to clear the ocean floor. So they'll take like a segment of the ocean and say, let's clear it of like find out what's debris, like what's natural, if there's any explosives in the area. And that amount of time that it used to take has now been cut in half thanks to AI. The AI uses sonar sensors to identify objects and can now be updated remotely in less than a week also. And the AI that's actually using this sonar system can be updated remotely in less than a week. So not over-the-air updates, but way closer than what they had before, which was compared to 6 months was what it used to take. And these underwater drones are already out there. They guess they're in the Indo-Pacific right now, and they're able to adapt to different ocean terrains, and they can make operations more efficient and safer. So OpenAI is now pushing into healthcare. We've seen Google do this. We've seen Microsoft do this. So I'm glad they're going into it too. I mean, I feel like that's a pretty good use of AI technology. So they teamed up with a company called Color Health, and they are bringing AI into cancer care. So they're using the GPT-4o model, and they're building an AI assistant, essentially a Copilot, like they brand all that stuff. And it helps doctors plan cancer screenings and pre-treatments. I mean, this sounds great to me. It analyzes patient records super quickly. It can handle way more records than the doctor's willing to read every single day. It can do that in about 5 minutes and spit out some suggestions that then the doctor can look into, right? The tool isn't meant to replace doctors. It's meant to aid them by taking over the tedious task of paperwork, the kind of data analysis, the details where it feels like sometimes the doctors have to keep their focus for so long that they can't quite think as much as they should about how to put all the pieces together. You know, like I want the doctor thinking a little bit more high level if possible. They have to know important historical facts and things too, but it'd be nice if a tool like this gives them suggestions or even points to like parts of the record that it used to make those decisions. And then the doctor can just use that as another source. But luckily it's part of a broader trend. Google and Microsoft are both doing similar projects in healthcare to streamline the process, but I haven't quite heard of it done specifically for the cancer care yet. So that seems like a great place to start. All right, tell me what you think about this clip. This is an Anthropic employee, and he says that there is semantic connections between concepts that are being connected by AI in unexpected ways. Or I'll just hear it from his voice.
I remember first finding this veganism feature that it was really cool, and I did not expect to see it. It was not even the biggest model, and I'm not a vegan, but disclaimer. But it was really interesting to see that the same model could identify the concept of not eating meat, of being worried about factory farming, and not wearing leather, but also in a lot of different languages. And the fact that it was able to tie all of these concepts together was I couldn't believe what I was seeing. The model actually, it's not just repeating it's not just repeating arbitrary words in some random way. It definitely, very concretely, this connection was already built into the model, and we just discovered it in there, and that really blew my mind.
So yeah, tell me your thoughts. I'd love to hear your thoughts on that clip in the comments below. But just the idea that veganism is a cultural phenomenon, not just a thing. It is a word. It's just like being vegan or eating vegan means a certain thing, but then not using leather and the cultural context of it and what you think about people who say they're vegan and people who aren't and how it affects the way restaurants market their products and stuff. All of that is actually captured in the distance mathematically between the word vegan and the word restaurant. But then also there's distances because it's multidimensional in there. It's really interesting that we're discovering this in the systems, and it's got to be telling us something about our human brains. All right, Grimlock, are you ready to transform into research?
Meet Grimlock, Bluetooth connection successful.
right, Grimlock, we'll save the universe one research paper at a time. All right, so the first paper we're going to talk about is MMBench-Video. It is a long-form multi-shot benchmark for holistic video understanding. This is a benchmark for testing models that look at videos. Okay, so it aims to evaluate how well large language vision models, so LVLMs, like LLMs, large language models, LVLMs, large video language models, can understand and interpret video content, like especially in terms of temporal reasoning and comprehension of like complex scenarios. Like if they're watching Game of Thrones, do they get what characters are doing what on screen besides just being able to identify like that's a chair and a person? Like that's what we're going for with this test. So the MMBench-Video used a variety of long form videos from YouTube to actually train it. Like it didn't focus on short form. It looked for diverse, human annotated questions that are thoroughly access the model's full capabilities. So here you can kind of see it's looking for all sorts of video emotion, video topic, causal reasoning. It's taken the main models that are out there and put this on this spider graph so you can kind of see which one covers the most area overall, what they're good and bad at, human motion, event recognition, stuff like that. And this is an overview of the ability dimension. So see, they're roughly broken into reasoning and perception, and then different amounts like the object character recognition, and then actual character recognition, and reasoning over what they're doing is all kind of broken into these areas. For the training data, they tried to balance it out in a way that's a little more fair. I guess it's not like they just took like random, like every long form video on YouTube randomly. They tried to make sure they were in categories where it could learn about people, science, pets, news, humor, stuff like that. And they broke down the longer form durations. And in the long run, the models basically show that none of them are very good yet, which is kind of true. Like it just feels like they don't really understand video, especially long form video, in a very great way yet. But that's why you build benchmarks like this in the early days so that you can see how they progress. All right, the next paper we're going to talk about is Whiteboard-of-Thought, thinking step-by-step across modalities. All right, so the goal of this paper was to improve visual reasoning capabilities. And this paper, Whiteboard-of-Thought, thinking step-by-step across modalities, introduced a method called Whiteboard-of-Thought. So they call it WOT for short in the paper. And it struck me as a little confusing at first because it's about improving the visual reasoning capabilities of a multimodal large language model, right? So this is a model that has language at its core, and then it's added the other layers on top of it. And why it would help for them to have this intermediate whiteboard to draw their like reasoning steps on. But then it occurred to me, okay, yeah, we've clearly done with LLMs a chain of thought reasoning and seen that that's beneficial. Like think through step by step very carefully. And now we can do the same because of this tool in the visual world. And that's why it needs a whiteboard to actually envision little things to then put them together. Like you have to envision, I guess, like a snail and then a boat, and then now make me an image of a snail on a boat, and it can do a better job. You really can't ask a diffusion model, like think step by step about what you're doing and get a better output. And this technique is doing something similar. It leverages the model's ability to write code using libraries like Matplotlib and Turtle to create visuals that help solve tasks involved in visual spatial reasoning. But because this is built into MLLM, so it's the multimodal but large language model, so they have word tokens at their core. The authors found that they can significantly outperform traditional chain of thought prompting on various tasks also. And that's the new thing here. It's the chain of thought aspect. And that includes an understanding of ASCII art, spatial navigation. The approach actually shows a 92% accuracy in challenging settings where like normally chain of thought would fail. So the paper highlights the power of WOT's potential to unlock visual thinking with a whiteboard in between step. And, just fascinating stuff. Bootstrapping language models, DPO implicit reward. So this research dives into a new method for making large language models better at understanding human preferences. Instead of using the traditional complex approach like reinforcement learning from human feedback, that RLHF thing where you like output a thing and then correct it with bunch of humans all the time, they focus on something simpler that they call direct preference optimization. That's what the DPO is. DPO is like a totally different paradigm, right? Like you skip that entire learning a reward model step and directly optimize the model using human preferences. So it's more like a watchful eye, I guess, of what you're doing, and then a self-correcting system, which is both creepier and seems like much faster at learning what we need it to learn about human preferences. So DPO gives an implicit reward model. The researchers had this idea that the implicit reward model would further improve the LLM by itself. It's an implied reward. And of course that makes it more general, so they had to create a new preference data set from the current model's rewards and then refine the model through several rounds. So it has to kind of learn its own reward function. It's like, I think I get like more pleasure, more reward points when, say, the person's like doing their dishes and I help them. But then if you kind of like, oh no, I don't want help right now, it's like, oh, I guess I had my reward function wrong, which is starting to feel like very human to me. Of course, this is just a large language model. That example was more like a robot in our real life, which will come one day. But this is more just like generating issues with long responses, with like lengthy penalties when it doesn't quite know how to reward its own sense of preference for what you want from a text output. And their approach, the whole pipeline, is called DICE, but it shows a significant improvement, even outperforming some of the existing models. And it was doing this with a very small LLM too, so it was just an 8 billion parameter model with no external feedback. So if they can get good results like that, it's probably something that they should try at a bigger scale, maybe something on like the new Llama model, and see if they could build a system refined at that scale, and then, maybe take it to the big leagues after that if it's that helpful. And now let's talk about multimodal needle in a haystack, benchmarking long context capabilities and multimodal large language models. All right, so this is another benchmark. I'm like on my benchmark kick right now, but this benchmark called multimodal needle in a haystack, the needle test, it's meant to evaluate how well multimodal large language models perform in handling long context scenarios. So you dump in the whole Harry Potter book and you ask about one thing, or you put in some weird random sentence that doesn't make any sense in the context of the Harry Potter book, and you ask it if it noticed anything weird in the book, and can it keep in memory, no matter where that point is, what went wrong. That's the needle in the haystack. But because it's a multimodal image, you're also doing this with images now. So you can put in a small object, the image of a needle, if you want, within a large set of images and see if it can, based on text descriptions, find it. So the benchmark is using techniques like image stitching to extend context lengths and includes data sets with 40,000 images and 560,000 captions. And it turns out that GPT-4 outperforms the other models. I mean, we already kind of know that's one of the best ones, except we got Claude Sonnet 3.5. We'll see. I don't think that was tested. But it still struggles with some hallucinating, especially when there's negative samples where the needle isn't present. But the benchmark does really point out that the big server ones, the API-based models, and like the open source ones like Llama are really in different categories. Like the API ones are still much better at handling complex and long complex tasks in a multimodal way. My eye healed. The views have been down, but that does not mean I'm going to find a way to burst a blood vessel in my eye ever again. If that ever happens again, it'll be completely accidental and not intentional. But I guess, could I get one red contact for when I'm filming? Probably, but that can't be, the channel can't just survive on whether my eye is red or not. Okay, guys, leave a comment. If you could hit that like button, those things really help the algorithm. Super thanks. That's super helpful. If you share it anywhere, I'd be super thankful for that. But here's my 3 favorite comments from the last video in the form of a song. We're definitely taking the super thanks comment. $5 from Taylor CKSO3. Thanks. Take this one. Don't mind sponsors as long as the companies are reliable and make sense. Yes, that's important. Oh, they really enjoy you, Grimlock. Really enjoying the Grimlock content. We're going to put that one in there. Wow, your eye looks better. Thanks for caring about my eye, everybody. Now let's turn this into let's do blues. We haven't done that one. Deep blues. Yeah, make it bassy.
Don't mind sponsors as long as the companies are reliable and make sense.
All right.
I'm really enjoying the Grimlock content, D.
Wow, your eye looks way better. Glad for you.
All right. Thanks for watching the video, guys. Hit subscribe. See you in the next video. That was fun. We definitely learned a lot about that crazy world out there, that big old countryside. Microsoft, OpenAI, it's a whole new world. All of us, we're gonna be in it together. Just singing my blues.